Good morning, everyone. I realize it may not be morning when you watch it, but that's when I'm making it, so good morning. Starting section 7.1, first thing you guys need to do is remember some properties from last semester. When you're multiplying and the bases are the same, you add your exponents, so that becomes x to the 8th. When these numbers are bases instead of variables, you still add your exponents. It's saying 3 times 3 times 3 times 3 times 3, and then 7 threes, 1, 2, 3, 4, 5, 6, 7. Okay, I'm counting and not writing. All right, so let me put 2 more on there. 3 times 3. How many 3's are there? It's 3 to the 12th. Notice that you don't multiply the numbers. It does not become 9 to the 12th. That's not what it says. No, it's 3 to the 12th. You leave the base alone and add your exponents. So it's 3 to the 5 plus 7 is 3 to the 12th. When you're multiplying, you can distribute your exponents in. So that's 3 to the 5th times 4 times x to the 2nd times 4. Oh, good grief. I'm battling with the 4's already, and I just started the video. All right. Times 4. So that becomes 3 to the 20th, x to the 8th. Okay. Here's some new ones. A root, this would be a square root. Remember, when the 2 isn't written there, it means a square root. So that would be a square root. All of these here would be square roots. This means exactly the same thing as 5, and there's a 1 here. 5 to the 1 half. The root is the denominator. So this would be the power. And this would be the root. Okay? So they mean exactly the same thing. The square root of 5 is exactly the same thing as 5 to the half. This, you could think of, okay, there's parentheses around it. It's 5x raised to the half power. And just like this one up above, where you distributed the exponent in, it means 5 to the half, because there's a 1 here and you're multiplying, there's a 1 there and you're multiplying, x to the half. If I had, let's see, 5 squared, whoop, let's not use square, let's use something different here. Let's go cube, because I don't want it to be too obvious. 5 cubed, and it's in a square root. That means the same thing as 5 cubed to the half power, which you multiply your exponents, so that becomes 5. The power is 3, and the root is 2. That means exactly the same thing as this. Okay, if you wanted to type it in your calculator, you could type square root 5 cubed, just like you always have, or using the new way, you'd go 5, the caret symbol, and then 3 divided by 2. And that would give you 5 to the 3 halves. Okay? When there's a variable inside, it doesn't change. That's the same thing as x to the half, because its power is 1 and the root is 2. This one, that would be 5x, and it's all being raised to the 1/2 power, and then outside it, this means that there's another parenthesis around it, and it's cubed. This would distribute inside, so you'd have 5x to the 3 halves, and then you could distribute that in because it's a product that's going on here. So that would be 5 to the 3 halves, x to the 3 halves. Okay? I think that's the last. Yep. Continuing the same theme, 7 to the 1/3. 12 to the 1/3. And this would be a cube root, so that would be 11 to the 1/3 power, and you're squaring it. The square just comes along. Then you distribute this in when you have an exponent on an exponent, like you had x cubed to the 5th power. That would be x to the 15th. Exponent on an exponent, you multiply your exponents. So I'm going to multiply these. So that would be 11 to the 2/3. It's squared and the root is 2. Now I didn't write that very well. Let me change that just so you guys see it a little more efficiently. It's 3/2. Okay? Now, on this next part, when you have negatives inside cube roots or any odd root, if it's a 5th root, and you have a negative inside. Let me back up and make sure that you guys are aware of, and it's in the forefront of your thought. If I have -2 times -2, I get +4. If you have -2 times -2 times -2 times -2, I have an even number of negative signs, I'm going to get positive. If I have -2 times -2 times -2 times -2 times -2 times -2. There's 1, 2, 3, 4, 5, 6. When you're multiplying an even number of times, your answer is positive. It should be something that you guys are comfortable with. I need to bring it in the forefront of your thought because what you need to realize is then if you have an odd number of negatives, your answer is negative. -2 times -2 times -2 times -2 times -2. So there's 5 negative signs. The answer is negative. An odd number of negative signs yields a negative answer. An even number of negative signs equals a positive answer. Okay? Why does that matter for what we're doing? An odd root is looking for the number of times that you're multiplying to get this thing inside. So I need what times itself 3 times is -1. Well, that's -1 times -1 times -1 is -1. This is looking for what times itself 3 times is -8. Well, that would be -2 times -2 times -2. This is looking for what times itself 3 times is -64. Okay? The answer is going to be a negative number because you're multiplying it an odd number of times. Your what times itself an odd number of times is this negative number. So automatically, your answer is going to be negative. If you like, what you can do is pop the negative out. Negative cube root of 1, negative cube root of 8, negative cube root of 64, negative cube root of 1,000. Because you know your answer is going to be negative, so this thing can just pop outside. Now, let's go back before I continue this. If I have a square root of -25, when you have an even root and that negative pops out, remember it pops out as I. And I was the square root of -1. So how you looked at this was it's -1 times 25. That's not a very good time symbol. It was a square root. So that's the square root of -1 times the square root of 25. So that becomes I, because that's what I is worth, times, and the square root of 25 is 5. So your answer becomes 5i. That's what happens when you have an even root. Odd roots, the negative can just pop out because you're looking for how many times does a number multiply an odd number of times and yields the number inside. So you know your answer is going to be negative because a negative number of times when you multiply a negative number gives you a negative answer. Okay, so back to this. That would be negative cube root of 1, and what times itself 3 times is 1? 1. This, the negative would pop out, negative cube root of 8, and you guys know what times itself 3 times is 8? Well, the answer is 2. Those are all times. So the answer is -2. This one, negative cube root of 64. What times itself 3 times is 64? Well, I know that's a little bit harder to do in your head, but 4 times 4 is 16, times 4 is 64. So that's negative cube root of 64, negative, and this much here is worth 4. So what's negative 4? This one, the negative pops out. What times itself 3 times is 1,000. I'm hoping you recognize 10 times 10 is 100. And then 100 times 10 is 1,000. So 10 cubed is 1,000. So this would be negative 10. Okay? When you have a negative inside an odd root, the negative just pops out. All right. There's 2 ways to type things like this into your calculator. I wish I could do all this live on the calculator, but I can't. There's 2 ways that you can type this in. One is to type it exactly as you see it. And that's what most of this here is going to be. To get a square root to show up on your calculator, you just hit the square root button. To get a cube root to show up on your calculator, you can go math, and there's cube root right there, the math button. It's on the left side of your calculator, and there's the cube root button. The one we're after is this one. It's not saying the variable is x. What you have to do is you have to type a 5 first. Whatever this root is, whatever that root, type that number first. So I type 5. Then hit math, the math button, and choose option 5, and what will pop out on the screen is this 5th root of 5. And then you just type the number in and hit enter. For example, if I wanted the 7th root, you would type 7 first, then math, then option 5, and what will pop out is the 7th root. Okay? On older versions of calculators, when you type the 7 first and then hit math, hit option 5, what will pop out is 7. This symbol will still have the x there, okay, on the older models of calculators. On the newer ones, it actually will produce the 7th root. The 7 will actually be there. So on the older ones, don't be alarmed if it doesn't look exactly like this. The point being is you have to hit the number of the root you want first. Now, obviously, if it's cube root, you choose that option. If you also, the option is you could type 3 first, and then math, option 5 again. I know that there's the option 4, but I'm just telling you, you don't have to choose that. If you wanted to choose option 5, you can do that. And then it will produce either this version, which will look like 3 with an X there, which I hate the notation, but that's how it does it on the older calculators, or it will actually pop out a cube root. Okay? Now, the other way that you can type it is this is exactly the same thing as negative 16,807 to the 1/3 power. And so you would type in parentheses negative 16,807. You have to put it in parentheses, then the caret symbol, and then a third. Depending on the version of your calculator, you may need to put parentheses around this. How will you know? Well, it depends on what shows up on your calculator. If you get this fractional exponent showing up like this as a fraction, then you don't need parentheses. It will understand what it's doing. If it doesn't show up on your calculator like this, if it shows up on your screen, negative 16,807, caret, that's not a very good caret. Let me change that. Caret, let's see. 1 divide 3. If it looks like that on your screen, it's not going to work. You need to put parentheses on it. If it doesn't display it as a fractional exponent, you need parentheses around the third. If it does show it as a fractional exponent, you don't need it. It will still work if you put the parentheses on any version of calculator, but it has to be there on the older versions. Okay. This one, how could you type it in? You could type it just as you see it. You could choose option 4, and it would show the cube root. Then you go 112, then you hit caret and a negative 4 and hit enter. On the newer versions of calculator, it will display it just like you see it. On the older versions of calculator, what you'll need to do is you can choose the math option 4, just like that. To get the negative 4 to show up, you'll have to go cube root, 112, caret, parenthesis negative 4 to get that all to show up in the exponent, and then it will display it just like that. Okay. The other way that you can type this in is I'm going to do just a little bit of math with it. This is going to be 112 to the 1/3 power, and then we still have the negative 4 hanging out here. So that's 112 to the negative 4/3. So you can just type this as you see it. 112, the caret symbol. On the newer versions of calculator, it will automatically bump it up into the exponent. It will be sitting up here. And then you can hit negative 4. I'm sorry that I typed like a 9, or wrote like a 9. On the older versions of calculator, you're going to need to put a parenthesis, divide 3. I know this initially looks like it's more work than typing this in as is, but as you guys get more comfortable with it, this will become more the standard, okay? You get used to it, all right? I know change is difficult, but this is also how you can type it in. You can type it in like this, okay? Solving equations with powers other than 2. So just to remind you, what you did here is you would square root both sides. Don't forget, when you put that square root symbol on the page and it wasn't there before, you need to put a plus and a minus, and you got the square root of 24. Now you're going to have to pull stuff out. Remember that that's going to be plus and minus, and that was a 4 times 6. Square root of 4 is 2. Plus or minus 2 square root of 6. You guys will always have to reduce your radicals. Always. Okay? It's not an option. Here, oh, let me back up. What you could also do is you could raise both sides to the reciprocal power. So you'd raise both sides to the half. And what you need to understand is you're putting an even root on the page, so you still get a plus or minus. You should get 24 to the half power, and then you have to reduce this. There's a 4 and a 6 hiding inside there. The 4 of this is going to pop out of the square root, so it's going to be plus or minus 2 times, whoops, okay, I'm confusing myself here. 6 to the half power. Now, I'm not saying there's an advantage necessarily to doing this. I'm just tying it into what we've been doing here. Okay? That would mean the same thing as I just did. This, you could raise both sides to the 5th root. You undo a 5th power with a 5th root. So you have x is equal to, it's an odd root, so you don't need a plus or minus. And this, I believe, is 3. Let me check it on the calculator quick. 243 raised to the 5th power. Yes, it's 3. I'd hate to make a mistake on these. Okay, so the answer, you would just type this in your calculator, and what would pop out is 3. If it was a decimal, I don't want it, okay? If it's a whole number, you're welcome to do it. The other way you could type that is you could raise both sides to the reciprocal power. Okay? So you have x is equal to 3 when you type that thing in your calculator. This one, you need to get rid of the negative first. X to the 7th equals negative 40. I'm sorry about that stupid 4. Alright. And then you would take the 7th root of both sides. 7th root, you need to indicate it's a 7th root. X is equal to, you put in odd root, so you know plus or minus. The negative's going to pop out. And I'm hoping by now you guys realize that there's nothing that's going to pull out of there. 40 is 2 and 20, 2 and 10, 2 and 5. So 40 is 2 cubed times 5 to the 1st. And you're taking the 7th root of it. None of the exponents are big enough, so nothing's going to come out. I realize y'all that didn't have me last semester, this may be a new idea and a new way to write it, but that's the reason I taught it last semester, is so when you guys get here, it's not that much to learn. It's like, oh, we've been doing that for a while, it's no big deal. Okay? If you don't understand what I did, I'm going to have to work with you and bring you up to speed on that. All right. This one, I can't touch the adding the 12 until I get rid of this 3. So you can take the cube root of both sides. Whoops. Cube root, and you have x plus 12 is equal to the cube root of 21. There's no plus or minus because it's an odd root. Nothing's going to come out of 21 because that's 3 times 7. None of the exponents are big enough, so it all stays. All the exponents are 1. Nothing's popping out. So now we can subtract 12. Negative 12 plus the cube root of 21. To see that with a fractional exponent, you would raise both sides to the 1/3 power. So you have x plus 12. We took an odd root, so there's no plus or minus. 21 to the 3rd. Subtract the 12. Okay, and you'd be done. I think that's the last screen. Yep. So there you go.